So this is my physics project. It's called a Rubens tube. What I did was take a 2-inch diameter steel tube, drilled 73 1/16 inch holes, ½ an inch between each on top. I capped off this end to be airtight. I added a little nozzle so I can inject it with propane. And then I made a latex diaphragm thing on this thing on the other side, so the sound waves can travel through it and it kind of acts like a drum. So I found that the speaker diameter has to be really close to the diameter of the tube, otherwise you won't, like, nothing will happen. So I had to make this little paper cone just to kind of fix that problem. Okay, so what's happening is sound waves, as most of you know, are compressional waves. So you can think of it like a slinky. Like if there was a slinky lying on this table right here, if you pushed one side, you'd see like a little compressed part moving through, and then behind that would be a little like more spread out, and then compressed and spread out. So that's how a sound wave moves. As the sound waves move through the propane in the tank, in the tube, the compressed areas will have more pressure and push out more propane, and the less compressed areas will have less pressure. So there will be less propane and less fire. So through this we can translate the compressional waves of sound into sine waves through fire. And now I'll just show you guys. Also, you can do many different equations with this. Like, you can use the speed of sound in propane, which is 247 meters per second. And say if you know the frequency, you can calculate what wavelength you should get, and you can measure it via the flames. Or you can verify the speed of sound in propane and get percent error. Or say, like, if I were to play trumpet into this and I played a certain note, we could measure the wavelength and calculate the frequency of what I was playing and compare it to what I was trying to play. And then, yeah, but really it's just a great visual aid and cool to look at. So. Okay. So first I will play a 440 hertz frequency. And I'll start with it kind of soft, and as I increase the volume, you guys can see what happens. All right, now I'll do a 700 hertz frequency. As you guys can see, the wavelengths are getting smaller. It's because the frequency is going up. And I'll do a 830 hertz frequency. Yeah, so that stuff's kind of cool and all, standing waves, but it's really interesting to look at when you play a song through it. So I had to find something appropriate, of course, and this is something most of you should recognize.